In this video clip, we will illustrate dependency relationships between objects in a dynamic geometry environment. First, let's create a line segment. To do so, select the Segment tool from the menu to the left of the sketch. To create a line segment, we must place the two endpoints of the segment. By default, GeoGebra automatically creates labels of any new points that are created, but does not automatically show labels of other objects, such as segments. This behavior can be changed if desired in the Settings menu, which is accessed by clicking the gear icon in the top right of the sketch. In this example, we will leave it as is. If we want to change the label of an object, make sure you have the Move tool selected and click on the object. Then click on the label icon. Here we can enter a new label for the object, as well as hide or show the label. If we click on the segment and select the label icon, we can see that GeoGebra has called this segment F. GeoGebra uses uppercase letters to refer to points and lowercase letters to refer to segments, lines, and vectors. Next, we will create a point on this segment. To do so, select the Point tool. Notice that the mouse pointer changes to a hand icon when it is over an object such as a segment. Make sure the pointer is a hand icon, then click on the segment. This creates a new point C on the segment. Now let's see how these 3 points behave differently when we drag them. Ensure the Move tool is selected and click and drag point A. Notice it can be dragged anywhere in the sketch. Likewise, point B can also be dragged anywhere in the sketch. This is because these points were arbitrarily placed. GeoGebra refers to these as free points. Now drag point C. Notice it behaves differently. It is constrained to only move along segment AB. That is because it was created as a point on that segment. It will retain this property throughout our attempts to move it. Thus, we can say it is dependent on line segment AB. In GeoGebra, you can use the Move tool and double-click on an object to see its definition. For example, if we double-click on the segment, we see that it is called segment F, and it is defined as a segment from point A to point B. It is dependent on point A and B. If we double-click on point C, we see it is defined as a point on segment F. Thus, it is dependent on segment F. If an object has other objects which depend on it, then deleting the object will also delete the objects that depend on it. For example, we can delete segment F by clicking on it with the Move tool and pressing the Delete key. Notice that point C is also deleted because it was dependent on the segment, but endpoints A and B remain. We can undo the delete by clicking the Undo icon in the top left of the sketch. Since point C has no objects which depend on it, that means we can delete point C without impacting the rest of the sketch. Finally, if I delete point A, then segment F is also deleted since it depended on both endpoints.